On March 19, 2026, Alexander Moiseev, Commander-in-Chief of the Russian Navy, confirmed that they will replace all third-generation nuclear-powered attack submarines with Project 885 Yasen and Project 885M Yasen-M units within the next 10 years. The new directive targets the full renewal of the Russian multipurpose nuclear submarine force that currently includes several dozen units derived from Soviet-era designs, many commissioned between 1985 and 1996. The transition implies a 1-for-1 or reduced replacement ratio, with an expected end-state fleet of about 10 to 12 Yasen-type submarines. This indicates a reduction in total hull numbers but an increase in per-unit capability. This initiative aligns with a broader Russian naval modernization effort that prioritizes underwater strike capability over surface fleet expansion. It also reflects an intent to standardize operational, maintenance, and training frameworks across a reduced number of submarine types, as it effectively replaces a mixed fleet architecture with a single dominant class. The submarines being replaced include boats from Projects 971 Akula, Project 945 945 A Sierra class, and 949A Oscar II, which were each optimized for a specific role, such as anti-submarine warfare and anti-carrier strike missions. These boats vary in displacement from roughly 8,000 to over 19,400 tons submerged and rely on older anti-ship missiles such as the P-700 Granit in the case of the Oscar II. Their maintenance burden has increased due to aging reactors, outdated electronics, parallel logistics chains, and distinct maintenance requirements tied to multiple design bureaus. The transition plan removes these distinctions and replaces them with a unified structure centered on Yasen-Class submarines. This reduces the number of hull types, certainly, but also the number of reactor types, combat systems, and spare part inventories. The removal of Oscar II units in particular reduces reliance on large, single-mission cruise missile carriers. The Yasen and Yasen-M submarines are fourth-generation nuclear-powered attack submarines with a submerged displacement of about 13,800 tons and a beam of 13 meters, with the improved Yasen-M variant shortened by about 9 meters compared to the length of the Yasen-Class, 139 meters. They are designed as multi-purpose submarines combining the roles of attack submarines and cruise missile carriers to execute anti-ship, anti-submarine, and land attack missions. The internal layout reflects this, with a large spherical sonar array in the bow and torpedo tubes relocated aft at an angle. The crew size is reduced to about 64 personnel in Yasen-M compared to about 85 in the original Yasen, indicating a higher level of onboard automation. The nuclear reactor, estimated at about 200 megawatts thermal output, is designed for a core life of up to 25 to 30 years without refueling. Submerged speeds are reported at up to 28 knots in quiet mode and higher at full power. Endurance is effectively unlimited except for food and maintenance constraints. The strike capability of the Yasen-Class is based on a vertical launch system with 8 modules, each capable of carrying multiple cruise missiles, for a total payload of up to 32 cruise missiles in standard configuration. The submarines can deploy caliber missiles for land attack strikes exceeding 1,500 kilometers, Onyx missiles for anti-ship missions, and Zircon hypersonic missiles, which have been progressively integrated into the class since 2024-2025. The presence of hypersonic missiles also introduces reduced reaction times for defensive systems. In addition to vertical launch systems, the Yasen-M submarines carry 10 533mm torpedo tubes capable of deploying up to 30 torpedoes, mines, and anti-submarine missiles. This dual capability allows them to simultaneously conduct strategic strikes and tactical engagements, replacing the fixed anti-ship loadouts of earlier classes such as Oscar II. Stealth performance is a central design feature of the Yasen-Class, with measures including a low magnetic steel hull with reduced acoustic signature, anechoic coatings, and a reactor cooling system that relies on natural circulation in certain operating modes to minimize pump noise. The sonar suite includes a large bow array, flank arrays along the hull, and a towed array for wide area and long-range detection coverage. This configuration improves detection capability across different frequency ranges. Compared to third-generation submarines, which relied on smaller sonar arrays and noisier propulsion systems, the Yasen-Class is designed to operate with reduced detectability. Reported submerged speeds reach up to 28 knots in quiet mode and higher at maximum output, allowing both stealthy patrol and rapid maneuver. This reduced noise profile supports covert patrols in contested maritime areas and increases survivability against anti-submarine warfare forces. Production of Yasen and Yasen-M submarines is concentrated at the Sevmash shipyard in Severodvinsk, which remains the primary facility for nuclear submarine construction in Russia. As of 2026, 1 Yasen submarine and 5 Yasen-M units are in service, with additional submarines such as Perm and Ulanovska under construction and planned, bringing the projected total to about 10 to 12 units. Unit cost estimates have ranged from about $700 million to over $1.5 billion, depending on the build period and exchange rates. Construction timelines have ranged from 8 years for later units to over 15 years for the lead boat, reflecting both funding cycles and technical challenges. Industrial constraints include delays in turbine supply, workforce limitations, and dependency on foreign production chains. These factors limit the annual output rate to roughly 1 submarine per year or less. Operational deployment of Yasen-class submarines is divided between the Northern Fleet, which operates in the Arctic and North Atlantic, and the Pacific Fleet, covering the Asia-Pacific region. Units such as Kazan operate in the Northern Fleet, while Novosibirsk and Krasnoyarsk are assigned to the Pacific Fleet, and have already conducted routine patrols and exercises. Their missions include tracking naval groups, conducting patrols, and maintaining readiness for strike operations against land and maritime targets. The transition to a single multipurpose class will change the Russian fleet structure by concentrating capabilities in fewer hulls. This reduces redundancy, crew training, and maintenance cycles, but increases reliance on each submarine. The integration of these submarines occurs alongside the deployment of Bore-class ballistic missile submarines, forming a combined strategic and conventional deterrent posture. From a strategic standpoint, the transition to a Yasen-centered submarine fleet expands the range of targets that can be engaged without forward basing of surface ships, including through the use of cruise and hypersonic missiles. This enhances Russia's ability to target naval formations, coastal infrastructure, and inland objectives without requiring forward deployment of surface forces. The shift has implications for maritime balances in the North Atlantic and Arctic, where submarine operations play a central role. However, the scale of transformation is constrained by Russia's production capacity, financial resources, and the availability of supporting systems such as surveillance and targeting networks. There are also indications that future submarine development will focus on smaller and less costly fifth-generation designs expected in the 2030s. This suggests that the Yasen-class may represent a peak in capability but also a transitional step toward longer-term restructuring.